Hello, friends. Welcome back. Today, this is part 10, I believe, of our tutorial on C++. And we're going to be talking about structures and enumerators. As you know, in C++, all the way up till now, we've been using what is known as legacy variables, right? We'll be using chars and, they call them primitive sometimes, primitive variables, long doubles. These are the ones that have been given to us by C++. Obviously, we have also char, and we have char as an array, which is a C string. Now, strings themselves are objects. Remember, if we include a string and we use strings, that's an object. They're not variables. But every programmer needs to have the availability to, have to be able to do their own variables. And that's what structures and enumerator types do in C++. We're going to start with a basic example of a structure. And here it is. It's an example of structure. I'm going to include the word string here, include string, because I'm using string. And then std, here's my structure. This is the basic structure. This is how you define it. I put in the word struct. Name is the name of my structure. Inside, in this case, I did string f name and L name and then int h. Obviously, you can see I could do any variable, or in this case, because I'm including string, I do strings as well. Now that I have defined my structure, and it ends with a semicolon right here, this is my structure. Now that I have defined my structure, I can use that name for any, like if it was a declaring a variable type, just like int or char. So I'm going to do name and any person. In this case, any person is a type name. Now, to access the elements, you put in the variable, in this case, any person, dot, and then whatever's inside, f name, L name, and h. In this case, I'm putting my name and my age. And to display them, I do the same thing. See out any person, that f name, last name, age, and that's it. This is a very simple example. I'm gonna go ahead and run it. And here's the output. Railhead is 55 years old. So you can see, I define my first name is Ray and Ojeda and then 55. And that's what it is. That's a basic, the most basic way of doing a structure in C++. Not much to it. Now let's go ahead and do another example. In this case, I'm going to go ahead and delete this, and through the magic of copy paste, I'm going to do an array of structures. So I'm going to do IO stream, obviously, string again. I'm going to include CC type. CC type, I'm using it because I'm using a loop that includes the toUpper function, okay? Now, here is my structure. It's called employee structure. I have an F name, a middle name, a last name, a department title, year of birth, and year hired. And I'm going to assume that we are in the year 2022, because that's what I'm doing this video for this example. Based on that, this is a more elaborate structure. I have employee structure, and this is the structure, and it's an array of maximum of 10 employees, because remember, starts from zero, starting from 0 all the way to 9. So that's what this does. Then I have a count, and I have a what you would call it, ages, and the E length is the length the employee's been with the company, the average, and the average age of the employee, and the average. So what this is going to do, and then I have my again, which is a char. What I did for this example, I just want to demonstrate the use of structures. So I'm going to do, and since I'm starting with a do while, right off the back, I'm asking for the first employee information: first name, middle name, last name, department, title, year of birth. I'm using getLine to get my strings. And once I get the year of birth, I can do the ages. Ages starts at 0 over here. See, that's a 0 right here. So now ages, assuming there is the year 2022, and I'm adding the year of the age of birth. Considering that we're in the year 2022, minus the year of birth will give me the age. And that's what I'm doing. I know I can get more complex on the month and all that, but I'm not doing that. It's just for demonstration purposes. And I'm doing the same for the hired year, right? Right there is a formula. So, and then I ask, do you want to do another employee? Yes, no. So this is going to be continuing until two things happen. One, my to upper is no. So while it's yes, it's going to continue, or while it's less than equal to 9. In other words, I have a maximum of 10 employees, and it has to, so I can do 3, I can do 7, I can do, whatever, but I cannot go over 10 employees starting from 0. Okay, so that's all the way to 9. And the calculations are easy because these two are doubles. I have to do this double, 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 or else it'll give me ints because these are ints. And we saw this in a previous tutorial chapter. So these are ints, so I'm making them doubles to be able to get a double. And then I print out the information. And here's my, because it's an array. See, this is what I would do here. The array, the subscript, and then dot, and then the actual element of the structure. So that goes for everything. This if here, what it's doing is if there's a middle and initial, if there's a middle and name, put the initial. If no, then don't put it, right? That's all it's doing, nothing else. I just don't want double blanks in there. And then the averages, very straightforward. Here is again the structure. And I'm gonna go ahead and run it. And what's going to happen now, I'm going to ask for first name. I'm going to put Ray Ojeda. Oh, I put middle name Ojeda. That's okay. I'll put Ojeda again. And I'm going to put in IT programmer. And I'm going to put 1966, 1990. Another employee, sure. I'm going to put in Mary J. Doe. I want to put a staff secretary, and she was born in 1980, 2001. And another employee. Let's do 3 employees. I'm gonna call John, no middle name, Doe. Let's say he's a cousin, even though I don't have any cousins Johns, but that's okay. I'm gonna put him in maintenance, janitor, 1970, and I don't know, 1980. Made up all this information basically. Another employee, I put in no, so now it should print out the results. So it prints first names, the middle initial if there is one, here there isn't, here there is, and I put in where they are. This is our title and our department. The average age is 50, and the average year for employees here is 31 years. So that's what this example does. Right, there's the information. You can try this program with any information you want. And here's the code. There's the code, obviously. Awesome, great. So that's how you do an array of structures. There's another example number 3. Okay, so what if I wanted to initialize the structure? What if I didn't want to put in, asking over and over and over and over? Of course, the loop program is the same. This is the same program, but I modified it. Again, don't let this fool you. Still string, F name, M name, L name, department, and title, and int your birth and your hired. Same variables, okay? I just put them on one line with commas instead of doing string and string and string and string. And the same name of the structure. Now here, what I'm doing is I'm declaring my structure, and I'm putting 7 elements, 1, 2, 3, 4, 5, 6, 7, starting from 0 over 6. And I'm pre-formatting the information, okay? I'm pre-formatting. Here in this case, there is no middle name, so I just put 2 quotes. Still have to have the space. And anyways, so yeah. Other than that, obviously I don't have a do while loop, at least not for that. What I do instead, I initialize my counter to 7 and everything else, and then I do my for. I'm using a for loop so that I can add the ages and the years hired. The rest is the same. So if I run this, here it is. Here's the employee information. And then here's my average and the length of years working. I don't have to input anything because I pre-formatted the information right here. That's how you do it. So I'm going to leave this slowly here, slowly here. There we go. Okay. Can I do structures within structures? Of course I can. You know, I was going to go there. So here's my my example. I have a structure of a personal called with my first name, middle name, last name, address, city, state, zip code, and the year you were born. I also have a structure, a position, which is a department, a position, and the year hired. See, I separate in two structures. Then I have the employee database structure, and guess what? It has an int for employee number right there. And then I have the other two structures for two different variables inside the structure. So how does this work? Well, it's very easy. And I pre-formatted the one because I'm just printing one record. E is the name of the structure, the first structure. Employee number, it was the variable, right? Employee number. And employee number, here we go. And then I give it a number, 1001. It's an int. That's this int right here. That's my first record. But then I go into the structure part, and it's E dot, then info right here is a structure of type personal. So info dot, and then I have to go to F name. There is no middle name. There is a last name. I didn't ask for the rest of the stuff. I just didn't want to do it. I could. I left it blank. They're empty right now. Then I go to the work. E dot work. Remember, work is the structure of type position, right? And I have department and position. And I didn't put year hire. I left them blank. And then I print them out. When I print them out, make sure you put the little periods in between the structures, right? So there it is. Ray Ojeda is a senior C++ programmer in information technology. So there's the code. Structures within structures and how you access them right there. Pretty straightforward, very easy stuff. My intention with these tutorials is not to break your head. It's to make sure you learn something. So anyways, I hope I've accomplished that. Now, can you pass structures to functions? Well, of course you can. And that's what this next example is. Here's my IO stream. I'm going with the numbers now. I'm going to go with the circle. The circle basically is a structure. It has a radius, R, and an area, A. And I have two functions. These are my prototypes. And I'm passing by reference for getting the circle. And I'm passing it the argument by value to print the circle. Why am I doing it like this? Well, here I'm passing by reference because I want to be able to update the value. Here, I'm just going to print it so I don't have to do it. I declare C is of type circle. So then I say get circle, and then I have %C, and then I print circle C. And that's what I do. So here's my actual function to get the information. What is the radius of the circle? I input C.R, right? There's my structure. Remember, passing by reference. So it's going to put it automatically. And then my area, there's my area, pi times the radius times the radius. And what is pi? Here's my pi value. Const double 3.1415. And I don't know, you can put as many values and numbers as you want, I guess. For practical purposes, good 6 numbers is good enough for a circle, for us anyways. And then when I'm going to print the circle, I'm just going to see out CA and CR. Right? I don't have to send the reference because I'm not going to do anything with it. I'm just gonna print the value. So, yeah, there it is. So let's do this. And what is the radius of the circle? I'm gonna do 10. And there it is, my area, 314.159, right? Very simple, very straightforward. So I'm passing a structure to a function both by reference and by value. So there it is. I'm going to do another example now. In this case, here is my circle again. Here's my const of pi. Here's my circle with the radius and area. Now notice that I have circle, get circle in this function. So circle is the structure and get function is a get circle is a function. So this is a function that returns a circle structure. Okay. There's nothing in there. So I declare C as circle, and I'm saying C equals get circle. It's a function. It's a function that's going to return a circle. So then I say C out the radius is C, right? C dot R and C dot A for my area and all that. Now, get circle, basically I have a temp of type circle. And once I get the radius with my sin, I calculate my area and I return temp. Return temp, which is a type circle, which is what I got to return. Remember, circle is a structure. So it's a function that returns a structure. Okay. And here it is the structure saying, hey, my structure equals this structure. Okay. So I'm going to run it again. I'm going to put 10. And there it is, 3.14159, right? So a structure defined that a function that returns a structure right there. And that's the main part of this example. Pretty straightforward. The next logical thing to do is a pointer to a structure. And there it is. So we have a structured circle with double R and A, and it looks in one line. Remember, I could do the spacing if you want. This just to make you feel better. That's fine. Here's my pi is a constant. Void, so there will be no returning on this. Get circle, that's the name of the function. Get C info, basically get C info is the name of the function. Circle is what I'm going to receive, and then it's a pointer. Remember, memory addresses, right? So I declare a variable of type circle, and then I do that and I send the memory address of circle, and then I print out the value. So what's happening is I'm getting the memory address. Remember, now, here is a little bit different than the other times. When you receive a pointer to a structure, you see this right here says it's a hyphen and a greater than. That is how you are pointing. It's supposed to be an arrow. It's supposed to be an arrow towards the item or element of the structure. So I'm saying input to my circle, which is C. Remember, there's my pointer C. So C. And that is how you do it. And now I'm saying the same thing with the area. C dash greater than A. This is a pointer to the element inside the structure. And I got the arrows right here. I call them the arrows. So this will do the same thing, basically 10. And there's my area. And I just noticed I needed an A there. So I guess I can put an A in there. So function with function that receives a pointer. Here it is. And this is the main thing of this example. This hyphen greater than. That's how you access the element inside when it's from a function, from a structure pointer. So, all right. Now let's do enumerators. Now, enumerators are another way to do your own variables in C++. Now, by default, enumerators are ints, okay? So when I say this is my enum is what you got to do to enumerator, enum. And then I put my name, days of the week. And then I start with Monday, Tuesday, Wednesday, Thursday, Friday. It could be anything. It could be the planet names. It could be the names of this. Just remember this. Monday equals 0, Tuesday. These are ints, literally. Except you cannot do traditional math with them. You can't say Monday plus 1. You get an error. Literally, you get an error. All right. So here's my n equals 7. This is a const. N equals 7. Int hours of n. This is an array. And t is 0. So for int equals int I, that means a new variable for only good for this loop. Remember, only for the local. From Monday through Sunday, I have plus plus. Why can't I do this? Well, I can do it because they're integers, right? Remember, they start at 0, 1, all the way to 6, so it's a total of 7. And then I'm gonna input the hours. I'm gonna input them into this array of ints. Then I'm gonna, in this for loop, all I'm gonna do is add them up, and I'm gonna tell you the number of hours. So let's see how it looks. So hours for work for day 0, which is Monday in this case. I'm gonna put in 8, 8, 8, 8, 8, and then 0 and 0, and then should be 40 hours. Now, obviously, I have names here, but when I print them out, it says 0 and 1 and 2. It can be a little complicated. We're gonna see how to display the names, okay? I'll show you how to do that. But before I do that, well, actually, a few things that I gotta tell you is you can give these different values. I could say, by default, this is 0, 1, 2, 3. I could do Thursday equals 10. Then from there on, this will be different numbers. There will be different numbers. I strongly suggest that you look into my blog at WordPress, which is Old School Programming. And really in there, I explain more in detail how you can alter the values of these here. How can you do some math with it and all that. For now, all I can tell you that is you can change the values. In the interest of time, I will do that. But I will include how can you say, not a link, but actually, you know what? I will put a link to underneath this video, I will put a link to the blog where I go in detail as to how you can change the values and how can you do some math with the enumerators, which is interesting. So hope you follow that link at the end of the video. But what if you want to convert enumerators into strings? There are 4 different ways that I can think of to do that. First and foremost is the switch way. And here it is. So here's my enumerator. I'm going to call this solar system. Solar system includes Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Uranus and Neptune, and sorry, no Pluto. I know. When I was born, Pluto was still a planet. That's all I can tell you. I'm a little upset about that, but it is what it is. Now, here's a function. Because I'm putting the function before my main function, I don't need to do a prototype, right? So we've been through this. I can put it in the top or I can put it in the bottom. If I put it in the bottom, I have to put a prototype. In this case, I don't have to. So void, so it's not going to return anything. It receives a number, int. And then I use switch depending on what the letter is. Remember, see, for 0 is Mercury, for 1 is Venus. So I just put in a string. See out Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And then I break, right? I break. So that's what the switch does. Now going to the main function, I say the planets are, and I put in the function, and then I put in, see, I'm using the name Mercury, Venus, because they're ints. And then I end the line. So it should just put in the names of the planets, and there they are, the names of the planets. That is the easiest way to print something. without getting too complicated, is just doing a switch with a number, putting in a function, and there it is. But it's not the only way. It's not the only way. Let's do another way. So I call this the array way. And there is the array way. So this is probably the second most common thing people do when they use enumerators. Here's my enumerator. I'm using the same example on all 4 examples that I got here because I want to make sure that you can see the difference between one and the other. In this case, I got a static const char and asterisk enum str. See, basically it's a static constant. It's not going to move. It's going to be everywhere the same. It's a static and const, and then it's an array of strings, and it has the names Mercury, Venus, Earth, Mars, all the way to Neptune. 8 planets. I know. I can't get over that Pluto thing. And here's my function. The planets are, now I'm going to do this. I'm going to call my string. This is my array. And the number, remember Mercury, Venus, remember they're ints. So that whatever number it is here, as long as it matches this, it'll print the same thing. I'm going to run it, and it should display the names of the planets, and there they are. So we know it's working. So this is the second. So the first one was the switch. This is the second one, is to make an array. That's all it is, an array. And I chose this. It could have been a string array. It doesn't really matter, as long as it's an array where the names match the order of the solar system. And there is an exception here, and I'll tell you right now. If any of these, if I would have done it equals 10 or 12 or 15, if I were alter the value of the int, obviously, when I call the string, the array, I have to do the same. Okay, that's a little disclaimer. Okay, I'm gonna do another example. This one is converting it. So here's my enumeration. Converting strings. So I'm using string right there. Instead of, one, I'm doing the others. Okay, so here's my same array. So far, so good, except I got string. Well, why did I have that? Well, string my planet, string, I'm returning a string, and it receives an int. And then I say string str of the enumeration, and then I return str. So what happens here? This here is declaring str of type string. That's why I have this. Don't get confused. String str, and then I'm giving it an initial value of whatever this int x is, getting it from my array, and then I'm returning the string. So instead of calling the array itself directly, I'm doing it through a function that returns the string. And there it is. It should print out the same. And there they are. That's the third way. Why would you want to do this? Because I'm doing an extra step. If you think about it, I can get it directly from here instead of over here. Just in case you want to know, one's a C string, the other one's a string. That's it. That's all I can tell you. Watch the other tutorials so you can see the difference between C strings and strings. But if you want one versus the other for whatever reason that you need in your program, specifically, this is how you will return a string, and the other one is a C string, okay? Now, there is one more way. This is a bonus because I have not written or talked about this in any tutorial, and it's called a macro. I'm not going to get too much into macros in C++ in my tutorial. I consider that to be an advanced feature of C++, but it's easy to use. Let's leave it at that for now. Again, I'm not going to get too much into detail. If you guys want to, you can just send me a text. I'll send you to a hell of a good tutorial on macros from other excellent programmers out there. Me, myself, I use it, but I don't think I'm very good at explaining it. But here it is. I'm going to define, and see, I've never used this word before, is define. I'm defining something. And this is what I'm defining: string ify, and then I have a name, is a something, and then I have pound and name. This is a macro. It's called a macro. This whole thing here is called a macro. All right. Don't worry too much into it. Like I said, I'm not going to explain what it is. It works. It just knows that it works. Here's my enumerator. Again, they're still ints, okay? Haven't done anything. Now, here is my array, but look at this. This is const char pointer, and then I have an array, and here I'm calling my macro, see, with the names of um, the planets. Then I have a function. Here's my function, void, and then solar system is the name of my enumerator, and planet. Obviously, I'm receiving a planet. So cout, convert enum of planet and L. This all it does is prints it. Now check this out. Display items, that calls this function, and then I send solar system of 0 through 7. Solar system, it's in parentheses. Remember what happens when I'm doing things in parentheses? I'll go back to the ints and the chars and the doubles. I'm forcing this 0 to be of type solar system. Okay, it's an enumerated type. I'm forcing this one to be of solar system. So trust me when I tell you this is gonna work. It's called a macro. This is a fancy way to do the same thing. If you are a beginner or even an intermediate C++ programmer, I strongly suggest you stick with the switch or even the array of with the C strings or the string. You can do one of those three. If you're an experienced programmer, obviously, I'm preaching to the priest here. So you should already know what a macro is, and this is my macro. Is this in conjunction with that? Here it is. I mean, I don't know how to explain. I'm very bad at explaining macros, which is why I'm not going to do that. But it works, and it works really good. Anyways, that is the small tutorial on structures and enumerators. At the end of this video, right before the usual YouTube click thing, I will put in a link, or actually in the description of my video, I put a link to my blog where I go more in detail about this because there's more to it, but not for the video. All right. Thank you very much. And I hope you keep enjoying these videos. Until next time.